Now we want to take the ideas that we've covered from earlier topics in this semester and begin applying them to functions with more than one independent variable. That is, functions that we refer to as multivariable functions. In example 1, we want to use the function below to find f of 1, 2. In order to evaluate multivariable functions, we follow the same rules and ideas that we did with single variable functions, but we have to start paying attention to which values correspond to x, which values correspond to y, and make sure we're making appropriate choices. So to evaluate f of 1, 2, everywhere we have an x in our function, we would plug in 1, and everywhere we have a y in our function, we would plug in 2. And in this case, we would get the function value 1 plus 4 or 5. That creates what's referred to as the ordered triple, similar to how we've had ordered pairs in the past, x, y. Now we have an ordered triple, which is composed of our x coordinate, our y coordinate, our function value, which in this case was 5, often referred to as our z coordinate. We have pictured the graph of this function, x squared plus y squared. Now that we have 3 variables, we're getting into 3-dimensional shapes, and we can at least briefly look at what it would mean to plot this ordered triple. Since our x value is 1, we would head in the x direction 1 unit. Our y value is 2, so we would head in the y value 2 units. We would find where those match up, and then we would draw a line straight up vertically until we intersect this cone. So the idea is still the same. We find where our x and our y values match up, but now we're just looking at a third direction, this variable z. That notion of paying close attention to our variables is also going to be important when we get into applications with multivariable functions. So in example 2, we have a local company that spends X thousands of dollars a year on online advertising, Y $1,000 on mailings and brochures. Total cost of advertising in thousands of dollars is given by this multivariable function. So we have an independent variable X and an independent variable Y. We could evaluate that function for these given values of X and Y, and the result that we would get would be 1,614.95. When we get into the interpretation, we'll have to pay close attention to what X represents and what Y represents. So our interpretation in this case would be when the company spends $18,829.20 once we make that unit conversion. That's our X value on online advertising. And then our Y coordinate, also multiplied by 1,000. Meaning we're spending $14,574.10 on mailings and brochures. Then the total advertising costs will be our function value, also multiplied by 1,000. So $1,614,950. So which value is X, which value is Y matters where we substitute into the function, but also how we complete any interpretations. We need to know which value correlates to which aspect of that word problem.